Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. The set of complex numbers. The set C defined as Z such that Z equals A plus BI, I square equal minus 1, and AB belongs to R square. The cross of two sets AB belongs to R square is called the set of complex numbers. If B equals 0, Z equals A is real. Hence, every real number is a complex number. Every real number can be written as A plus BI where B equals 0. Then every real number is a complex number. We got N subset Z, subset D, the set of decimal numbers, subset Q, subset R, subset C, subset question mark. You will see later on subset what. Give a number which belongs to Z and doesn't belong to N. We have many numbers belong to N, to Z. We have many numbers belong to Z and not belonging to N. For example, minus 5 belongs to Z and minus 5 does not belong to N. Give a number which belongs to C and doesn't belong to R. Which number belongs to C and doesn't belong to R? We should have B different from 0. Z equal A plus BI such that B different from 0. Z equals 2 minus 3I belongs to C and Z doesn't belong to R. We use the laws of addition, subtraction, multiplication, and division in C as we use them exactly in the set R. Okay. How? Let us see. How to add A plus IB, C plus ID. A plus C, I common factor B plus D. How to multiply A plus BI into C plus DI? A times C plus A times DI plus BI times C plus BI times DI. BI times DI is BD times I square equal minus 1. I square equal minus 1, so we have in the real part AC minus BD. In the imaginary part, when we take I common factor, BC plus AD. Examples: 2 minus 3I plus 5 plus 2I, real plus real, 7. Imaginary plus imaginary, minus 3I plus 2I minus I. Multiplication: 2 minus 3I into 5 plus 2I, 10, 2 times 5, 10, 2 times 2I, 4I, minus 3I times 5, minus 15I, minus 3I times 2I, I times I square minus 1, and minus, we have a plus 6, So this is 16 minus 11I. Division. When we divide two complex numbers, we have to multiply the denominator by its conjugate. The conjugate of C plus DI is C minus DI. Conjugate to get a real number in the denominator. So A plus BI into over C plus DI equals AD plus BD over C square plus D square plus IBC minus AD over C square plus D square. Numerical: 3 minus 2I over 2 minus I over 3 minus 2I. The conjugate of 3 minus 2I is 3 plus 2I. We multiply up and down by 3 plus 2I. 2 times 3, 6. 2 times 2I, 4I. Minus 3I, minus 2I square. Minus 2I square. But I square minus 1, so plus 2. Over x square plus over c square plus d square, which is 9 plus 4. 3 square plus 2 square equals 8 over 13 plus 1 over 13i. The real part is 8 over 13 and the imaginary part is 1 over 13. Two complex numbers are equal when they have the same image. For example, a plus ib equals c plus id. The image of a plus ib is the point of coordinates ab, and the image of c plus id is the point of coordinates cd. They have the same image. It means a equals c and b equals d. Conjugate of a complex number. If z equals x plus iy, z bar equals x minus iy is called the conjugate of z. Z times z bar, we multiply z times z bar, we get x squared plus y squared, which is a real number. This is in the form a plus ib, a minus ib, a square minus b square, I square minus 1, so plus y square. Z times z bar is always a real number. Example, z equals 4 minus I, z times z bar, 4 minus I into 4 plus I equals 16 plus 1, 17. The same, 9 plus 4, 13, minus 3, minus 3 square plus 0 square, 9. Z equals 4I, the real part here is 0, 0 square plus 4 square, 16. If z belongs to R, z bar equals z. For example, if z equals 7, z bar equals 7, because z equals 7 plus 0i. Z bar equals 7 minus 0i, still have 7. If z equals x minus 1 plus I into y plus 2, then z bar equals z, if and only if x minus 1 plus I into y plus 2 equals x minus 1 into minus I into y plus 2. They have the same image. It means the real part of z equal to the real part of z bar, x minus 1, and the imaginary part of z bar equal the imaginary part of z. We get y plus 2 equal minus y minus 2, 2y equal minus 4, y equals minus 2. Or you can say directly, if z equals x minus 1 plus iy plus 2, z bar equals z, then z is a real number. Z is a real number when y plus 2 equals 0, y equals minus 2. Properties. Z plus z prime bar equals z bar plus z prime bar. Why? Let z equal x plus iy and z prime equals x prime plus iy prime. Z plus z prime, x plus x prime plus iy plus y prime. Z plus z prime bar, we have to change the sign of the imaginary part. So x plus x prime minus iy plus y prime. We expand, we get x minus iy plus x prime minus iy prime. Second property, we can prove it as we prove in 1. Z over z prime bar is z bar over z prime bar. You can take z equal x plus iy as z prime equal x prime plus iy prime. You will find z over z prime, then the conjugate, and you will make z bar over z prime bar, and you compare, you get the same answer. Similarly, zn bar equals z bar to the power n. Z bar to the power n. For example, if z equals 2 minus 3i, z square a minus b square equals minus 5 minus 12i. The conjugate of z square is minus 5 plus 12i. Now we make z bar. Z bar is 2 plus 3i. Z bar square equals how much? Minus 5 plus 12i. The same. Then z square bar is z bar square. Exercise. Given z equals 2 minus 5i and designate by a its image in orthonormal system. Calculate real z bar and imaginary z bar and find the coordinates of V, the image of z bar. Real of z bar. Z bar is 2 plus 5i. Z bar is 2 plus 5i. Real of z bar 2, imaginary of z bar equals 5. Its image B is 2, 5. Calculate z bar times z, z plus z bar, and z minus z bar. Z bar times z, z bar times z, z bar times z equals how much? X square plus y square. X square plus y square, 4 plus 25 equals 29. Z plus z bar, when we add z and z bar, we will get 4 equals 2 real of z. 2 real of z. If here we have x minus iy and x plus iy, when we add them, we will get 2x, 2 real z. Z minus z bar equal minus 2i, minus 10i equals 2i common factor, imaginary of z. Imaginary of z. Imaginary of z is minus 5. Minus 5. We multiply 2i times minus 5. We get minus 10i. 2i imaginary of z. Z minus z bar always equals 2i imaginary of z. Calculate the real number a such that the z plus ia belongs to r. So we have to write z plus ia in algebraic form, and to get a real number we should have the imaginary part of the obtained complex number is 0. The imaginary part, a minus 5 equals 0, a equals 5. Thanks for following and good luck.